So, hello everyone. Are you able to hear me?
Yes, sir. Good evening.
Yeah. Good evening.
Yes, sir. Good evening. We are able to hear you.
Okay. So we are here for the third week, and we'll discuss the concept related to third week. Okay. So how should I approach? Whether you have any doubts in the activity practice or the graded question, or should I explain the basic, what you can say, concept related to third week? What do you want? Can somebody say?
Sir, I think at the moment, already gone through the topics, but still you can take your time to explain the required actually kind of basics along with the queries. Especially yesterday, ma'am told she is going to explain about the Markov inequality theorem, like some of the topics like which is very difficult.
See, in the third week you don't have much like concept. So you have only expectation, variance, covariance, correlation, and Markov and Chebyshev inequality.
No, sir. Hello, sir.
Yeah.
I think what he's trying to say that the important concept, like say for example, what I think for me, which I have not understood well. Say for example, standardized random variable, right? And then both the inequalities, like this kind of important concepts.
Okay.
So and there are a couple of derivations. You know what happens when we are watching the recorded video. You know, so it's a one-way communication. So for example, some doubt comes to mind, so we are not in a position to solve it immediately. So this kind of concept discussion class is very helpful.
Okay.
Sir, if you could summarize week 3's concepts, it would really be a big help.
Okay.
Sometimes it gives us a broader picture, overall picture.
How many of you have seen the lectures of third week?
We have seen.
Okay, so 3, 4
Yes, sir.
people.
Yes, I have seen.
So what is the question, sir? What is the question?
So how many of you have seen the lectures of third week, all the content?
Yeah, we have seen actually, sir.
Oh, okay. And have you tried to solve all the questions of activity and practices?
Yes, sir. We tried, sir. Only problem like just in one example, like okay, we can say the inequality theorem side. So we are not able to apply that concept actually, sir. In the question. So maybe the theory is not clear for us. So that's the thing, sir. We asking your help.
Okay. So are you able to see my display? Is it visible to everyone?
Yeah, for me it's visible, sir.
Okay. So I'll just write it down. So one is the Markov. Second is the Chebyshev.
Third is standard random variable.
Okay, standard random variable. This is nothing like just pretty simple one.
It's not a question of the formula, sir. Formula is very simple: x minus mu by sigma. I'm just trying to understand it intuitively. Like when we say that the mean becomes 0 and standard deviation becomes 1, then what we mean by it actually?
Okay.
How can my random variable take the mean 0? So that kind of might be a very silly doubts, but that kind of doubt comes to mind.
Okay. So any other thing?
Formula is clear, sir. Even for Markov and Chebyshev also, we put the value, we get the answer. That is not the problem. The problem is the intuitive understanding of those concepts.
Okay. So anything else? Like I'll write the topics, all the topics. So one is the expectation. I don't think so there will be any issue. The second is the variance. The third is the covariance. Correlation. Okay, these 4 topics and this 2 and 1. So I'll be discussing this 3. If you are having any doubt in this also, you can ask. Okay. Anybody has been any issue in this 4 topics? Expectation, what is expectation, or how to calculate the expectation, or the variance or the covariance of x and y, or how to get the correlation between two functions, two random variables. If you're having an issue, you can ask me from these all topics also. Okay. So I'll start from the lecture first itself. Okay, and then I'll go till the end lecture. Okay.
Sir,
So
actually, in decoding these questions, what you are giving for expectation, variance, and covariance kind of thing, if you do, it is one of the questions, then it will be easier for us. At least,
I'll try to solve.
No,
the question.
we are not asking to solve you completely, sir. But
I'll just give you the brief. I'll not solve
Thank
any
you.
of the
Thank you.
You give the brief introduction.
Okay. So see. So in the first lecture, Sir had just talked about the expected value of any random variables. Okay. So how to calculate that? So why do generally we need expectation? Okay. So for example, if I'm having a large set of data, okay. So first I'll explain the expectation. That will not take much, like more than one expectation. Okay. So if I'm having large set of data, okay, so like for example, if I'm on a very large set of data, like for example, the marks. So my voice is audible, right? There's no issue in that voice, right?
Some background noise is coming, sir.
It's really feeble, if you ask me.
Okay, so I'm in the office, so maybe the background noise would be there, but I'll try to speak it louder.
You can change that one by using your Zoom microphone adjustment and the settings itself, sir. It is very easy.
Okay, 1 second. Give me 10 seconds. I'll try to do that.
Yeah, please. Thank you.
Yeah. Hello. Is it fine now?
Perfect, sir. I can say.
It's much better, I think. Yeah.
Okay. Yeah. So there was an issue, like I was in the office, and so there was a bit like background. Somebody was talking. So I just replace the place. Yeah. Okay. So I was just talking about so what we'll be doing. I'll be just going through these topics. Okay. These are all basic topics you already have studied in the stats. One. So I'll just go through that. If you're having any issue in between, you can ask me. If you're having any issue in the practice assignment or any of the activity also, I'll just try to give you the concept how to solve it. I'll not solve whole the problem, okay? Because in this 2 hours, I'll be trying to cover up everything of the third week, so that if somebody has not seen the lectures also, we'll be trying to solve the graded assignment before the submission, okay? Yeah. So the first thing is expectation. So the expectation generally, if we are having a large set of data set, like for example, the marks of a whole classroom, okay, now or the marks of the classroom of any subject, okay, marks of student is the one example, or you can say the run scored by any batsman, okay, by wicket, okay. So how generally we get an idea? Like we can't just say all the marks of the whole student. Like I'm having student of 100, a classroom of 100 students. So it's better to just say regarding the average value of the marks. Average value of the marks of, like, if I'm having 5 classrooms, A, B, C, D. So this is a class 10th, sorry, class 11 with the 3 batches, okay, of class 11. If I'm having the average value of the marks of the class A of some mathematics, okay, so I can say that if alpha, this is alpha, this is beta, and this is gamma. If somebody is asking regarding the marks, average marks, so that is the one way to describe the marks, whole marks, right? So it's like, for example, alpha is better than beta, alpha is greater than beta, right? So that one person can say that the class A is performing better in math than B, right? Okay. So similarly, if that depends on the alpha, beta, gamma, right? So the expected value. Similarly, the run is scored by the, if we have to judge any batsman also. So generally we look after the average, or you can say the average score, average run scored by any batsman. Or if you have to see any record regarding the bowler also, we generally look after the average number of wickets generally he takes, or the average there's a strike rate in the bowling options also. Okay, so that is the one major, you can say, the important thing, that if I'm having a large chunk of data with the value of average or with the value of the expectation, you can say directly. Okay, and in the variance, like for example, like this is the expected value, but whenever if I'm having some sort of data, and those data, like for example, I'm having data like 0 and 20. Okay, so if I'm having only 2 observations, and the second observation is 10 and 20. Like for example, I was saying this is a class A, this is a class B, and this is class C. Okay. Class C, you can assume anything, like, for example, what any number, can somebody say any number between, so that the average will come at 10. Like, for example, this also will be having average as 10, right? Average marks as 10. Here also the average marks would be 10. And for example,
8 and 12.
8 and 12. Okay, so the average marks will be 10 only, right? But the average is 10. So we can't say anything about, with the average, only with the average value, we can't say anything about the student of that class regarding the marks of the marks. Okay. But if we are having the variance also with expectation, right? Variance, then we can see which of the classes has performed well, right? So the variance is also one of the important aspects apart from the expectation, okay? Because the expected value of all the 3 classes were same, but the variance, when we'll calculate the variance, how the values are splitted over, or how the values of the marks has been splitted over, which like splitted over which like number, or you can say how much the value has been splitted. Okay, like for example, here the difference you can see is 20, right? So one student has performed very bad and one student has performed very well, but we are getting the average as 10 only, right? And in this B is very good, like all of the students are like are able to score 10 marks, right? In the C is one person is scoring a bit bad and one generally scored a bit good than the average, right? So if you are having expectation plus variance, that is a very good thing to know about the any data set, right? So that is why generally we calculate the variance. So I'll just tell you the basic formula that you already know, but I'll just write it. Okay. So if I'm having x is the outcome, and the fx is the probability of screen of x, right? That you have to integrate, and if this is a continuous, and if you are considering the discrete, then you have to do the summation of all the t with the probability of x equals to 2. So this for the continuous. If you are getting some continuous, then you can calculate the expectation like this. And if you have the discrete data set, you can calculate the expectation like this. Okay, one important formula, and I'll just go through the problems also. That I don't think so we'll be having any issue in solving the problem. Okay, so this for example, I'm saying I am throwing a dice. Okay, throwing a dice can be from 1 to 6, right? So what is the expected number that you will get if you are throwing a dice? Okay, so till 1 to 6, right? So the number that if I'm throwing a dice, So this out of the 6, anything can be possible, right? So the expected number, who is that? Can you mute yourself? Okay. So yeah. So if I'm having, like, for example, I'm throwing a dice, and that dice is generally having the 6 aspects that can come after throwing a dice. The front part of the dice can have 1 to 6 number, right? So if somebody is asking you to calculate the expected number that will get after throwing a dice, okay, so that is what generally the probability of getting 1 is what, 1 upon 6. So similarly for all the other cases, because it's a fair dice, there's no what you can say, the what generally you say, this is totally a fair dice. There is no biasness in the dice. So all the probability of getting each number is 1 upon 6. Okay. So how generally you calculate the expectation? You generally calculate this expectation as this is 1 was the outcome, 1 into 1 upon 6, 2 into 1 upon 6. So this is a one way. If our data set is discrete, then you can calculate the expectation like this. Okay, this is the expectation for x, and you'll get as 3.5. So one of the most important thing is the expected value can be different from the whatever the outcome, like the sample space you're having. Like for example, here the sample space is got 1 to 6, but you have got the expected value of 3.5 types. So this can happen because this is simply we are calculating average value that you can get out of the 6 numbers, right? So that can be a different number from the sample space. That is the one thing. So it's a pretty important, what you can say, the properties of the expectation. Okay. So similarly, you can calculate the variance also. So variance is what? Variance generally you can calculate. So variance is simply one expectation of x square minus mu square. Mu is simply what? Mu is the mean, whatever we have calculated, or the expected value, whatever we have calculated. That with this value. So you'll get the variance also from here. Okay. So I'll just go through some questions of the first.
Sir,
Can
I ask a question here? Can I ask a question here, sir?
Yeah. You can ask.
Sir, can you you showed us the expected value of rolling a fair die is 3.5, like whatever we can get. So also there is the other thing for binomial distributions. Let's say we get the mean to be NP, right, sir?
Yeah.
So, like for instance, if P is 1/6, and if I roll it say 500 times or something like that.
500 times, and P is
or
what?
maybe even 6 times for that matter, or even 6 times if N is 6. So
and
what is this expectation value I'm getting? For which random variable am I getting the expectation? Because I'm unable to reconcile between the 3.5 thing and this NP thing. Can you clarify this a bit, sir?
Your voice is like not clear. What you told, and we are throwing a dice. What throwing a? What you told? We are throwing
a dice 6 times, right, sir? And I say my random variable is calculating the probability. My random variable is trying to calculate how many times I get a 4 or a 5 or whatever it is, sir. The probability is 1/6, right?
Okay.
So NP is going to give me my expectation value or the mean, right?
But this is a uniform distribution, right?
What?
But in NP
No,
is only. NP is only going to give you the expected value for a binomial distribution, but this is
so the binomial distribution case will not be applicable over here. Is that it for the fair die?
Yeah, it can be, but if you take,
you have to define this in a form of binomial. Then one will be able to.
So this is if you can just quickly explain like when to go for the uniform. How should we approach the? This is increasingly difficult while approaching a problem. So this is where I'm coming from, sir. Like one time we are looking at an expectation value of 3.5, and then we go to NP, it will go to a different value. Like for instance, if we multiply the expectation like into 2x equal to 2 into e of x, right, sir? So those things are I'm getting a bit confused, sir.
Okay, see, if you have to see how come this NP can't be applied to this. This can be applied, but you have to convert that into a binomial condition. Okay, like for the tosses, what you are having either the success or the failure, right? So if you have to convert this into a die form, so what you will do? So you have to define that random variable as like for example, you have to get 6 out of that out of the 6 number. So you can define x equals to 1 when you are you are getting 6, right? And x equals to 0 when you are getting any other value. Like for example, 1 to 5. If you are getting 1 to 5, you can define that random variable as 0. And if you are getting only 6, you can define this as a 1, right? So this problem is what? This problem is the number of 6 you are getting, right? Are you getting my point?
Yeah, I think I'm getting it.
Yeah. So if the question is asking you, what is the number of x, what is the number of 6 you will get, then you can define this in this form, and then you can apply this NP. In that case, the probability will be 1 upon 6, right? And the Q will be what? 5 upon 6. Are you getting my point? So
yes, I'm getting your point.
Yeah. So in that case, you can apply, but in this case, you can't apply the expected number of value. Expected number of value you will get after throwing the dice. So that is different thing apart from that. So binomial you can do only binomial. You can apply only NP thing only if you are able to convert that problem into a success or failure thing, right? For example, I have converted here. X equals to 1 means what? I'm getting 6, and I'm getting any other thing. I'm writing it 0. That means either success or failure. The probability of getting success is 1 upon 6, but the probability of getting non-failure is 5 upon 6. Then you can apply NP. Otherwise, you can't apply. I got
you. Thank you so much.
Yeah. Okay. So I'll move to
the. Can you move a little bit upward?
Yeah.
Move. Yeah. So actually, I need to write that variance formula.
Oh, okay. Okay. You can write this. This is one of the simplest method to calculate the variance. So don't go with like the bulkier problem, like expectation of that what x minus expectation of x whole is. Like this is also the same thing, but yeah, you can just whenever you have been asked to calculate the variance, just calculate the expectation of x square. X square is what? X square you have to multiply with the probability whatever you're getting of that. Yeah. Okay, you have to do the integration, or you can do the summation of all the values, right? And this you have already calculated x into fx summation, and you can just square. That is simply the mean value. Okay.
Yes, sir. Thank you.
Yeah.
Done.
Yeah. So I'll just try to solve the sum question. So the first question, I don't think so. There, yeah. Go ahead.
Yes, sir. I have a problem in the question after this.
Okay. So the first question, I don't think so there is any issue. Like the profit is 10,000. If the probability, so you just have to multiply this thing, and for the loss, you can just you can multiply minus 5,000 into 0.45. You'll get the expected gain. Okay. Right. So there's no issue. Yeah. And the second question, you're having doubt, right?
Okay. No, sir. No.
Okay.
After this, I tell you the question number.
So I'll just go through that. It will not take more than 1 minute to discuss all this question. So in the second question, expectation of x, you have to calculate. What you have to do? Expectation of x is what? X into the probability of getting x, right? So you just have to 3 into 1 upon 2. Multiply these all things and do the addition. You'll get the expected value of x. Okay.
Yes. Sir.
So most of the questions are almost same. In the third question.
Yes, sir. Third
okay.
question.
So the third question is the coin is biased. So this coin is not fair. First of all, such that the head is likely to occur 3 times more than a tail. Okay, so the probability of, like for example, you can just assume the probability of getting tail is x. Then what is the probability of getting head? That is 3x, right?
Yes.
So x plus 3x will be what? 1, because this is basic property of probability that the summation of all the probability value will be equals to 1, right?
Yes, sir.
Okay, so x plus 3x will be what? 1. So 4x equals to 1, so x equals to 1 upon 4. Are you getting my point?
Yes.
So yeah. So now what you have to calculate? So focus on the thing has been asked. Like for example, here it has been asked, find the expected number of head when you are tossing a coin twice. So if you are tossing a coin twice, what else you can get if you are tossing a coin twice? So what else thing you can get if you are tossing yeah. So head you can get, right?
Yes, sir.
You can get head tail. You
Yeah,
can get tail head.
Yeah.
And you can get tail. Right?
Yes, sir.
So here it has been asked expected number of head you are getting, right?
Yes.
Okay. So here the x value will be what? Just for example, you have assumed the random variable as x, where x is showing the number of the head. So here it is x equals to 2. Correct?
1.
Yeah, 1. Here
1, 0.
1. Here it is 0, right? How generally you calculate expectation? X into the probability value, and you do the summation, right?
Yes, sir.
Okay. So x equals to 2 into probability of getting head. What is the probability of getting head? Tell me.
1 by 4.
1 by 4.
1 by 4 into 1 by 4.
1 by 4 into 1 by, not 1, 3 by
3
4
by
into
4.
3 by 4.
Oh, sorry.
Right? So the probability of getting head was what? We have calculated. I've told you x plus 3x
Yeah,
equal to
yes.
1, x equals to 1 upon 4, right?
Yes.
Yes, sir.
Probability of getting head is 3 upon 4, and similarly for
2,
this
3
also
by
3 upon 4. So we'll be having 9 upon 16, right? Similarly
Yes.
for this one, do the summation 1 into what? Probability of getting head is what? 3 upon 4.
Into 1 by 4.
Probability of getting tail is what? 1 upon 4. Similarly, you can do for this also, and this you can cancel because x equals to 0, right? So you have to just do the summation of this 2 plus 1 into 3 upon 4 into 1 upon 4. This for this one. And you'll do the summation, you'll get the value. Are you getting my point, or should I explain it more?
No,
Hello, sir. Thank you.
You got it. Okay, thank you. So we'll move to the next one.
Same notes as NP reference.
Are somebody asking something? Like your voice is not clear.
Yeah, can you show that notes once again, sir?
Should I show it once more?
Yes, sir. No, not this one, sir. Can you scroll up? And the earlier example
Sure.
you have taken some NP something. What is this NP? Actually, joining the
Okay, so NP is for the binomial. Like if you are using, if you are, this is the expected value for the binomial thing. Okay, like for example, I'm tossing a coin 10 times. Okay, what is the expected? Okay, so this for the binomial, like if you're tossing the coin 10 times, right? And then you have to calculate the expected number of head and tail, right? So you can just n into p, you can directly write it. So I was explaining just the, if you don't have the binomial condition also, you have to convert that into binomial condition. Then only you'll be able to do this NP and NPQ. Okay,
So
NPQ is simply the variance.
N is the number of trials.
Yeah, n is the number of trial, like the binomial you already know, right? Binomial, how generally you show n in NP. N is the number of trial and P is the probability of getting head or tail. Okay. Okay, so I guess,
Sir,
yeah.
I have a doubt, sir. This is related to properties, not to numericals. Numericals are fine.
Okay.
Sir, say for example, if my variables are independent, right? X and Y are independent, then expected value of X1, X and Y we write EX into EY, right?
Yeah,
expected
correct.
value of XY we write EX into EY. So now I have two doubts. What about dependent? If my variables are dependent, then how to find? That is question number 1. And question number 2 is that what about other cases like X minus Y and X divided by Y? If say for example, if we get this kind of question that
so you are asking how to calculate XY if X and Y are dependent, right?
That is first part of my question.
This you can calculate like this. This XY multiplied with, you will be having the box of XY, like for example, FXY, and that you have to do the summation. That's the first question. If in the case of dependent, this is how you calculate.
In case of discrete variables, sir? In case of discrete random variables, right now
do the summation. Do the summation. Like for example, if I'm having the table, there is a x equals to 1, this is x equals to 2, this y equals to 1, y equals to 2. So this is what?
Okay.
This is fx f1 comma 1, right?
Okay.
F of 1 comma 2. So similarly, you can
2 comma 1. That will be 2 comma 1.
2 comma 1, whatever. Like I just writing 2 comma 2, and this is f of 1 comma 2, right? So you can just write the xy and then write the fxy and do the summation.
So what you are suggesting that read xy, the product of xy is one variable, right? That's what you are suggesting.
So every time, whenever you have to calculate the expectation, whatever the function, I'm just taking fx or gx. So just write the gx here and write the probability related to gx here. Okay, and do the summation of all. Or if it's continuous, do the integration of all. So you'll get the expected value. Am I clear?
Yes, sir. The second part, sir, like if we get like x minus y or x by y.
So can you explain it? Like I didn't heard your second point. Can
okay. Say for example, if we got to calculate expected value of x minus y. X and y are my two random variables.
So you have to calculate the expectation of x minus y.
Right.
Okay.
And then the second one is e of x by y. E of x by y.
E of x by y.
Yes.
Okay, so x minus y is simple, right? Ex minus ey. In the variance, if you have to calculate the variance of x minus y, then you will do the summation because you already know that minus square generally. So in the variance, generally, you have to do the square of the thing. So if you have to calculate the variance of x minus y, then you will write variance of x plus variance of y, or you can say the variance of minus of 1 square variance of y, right? The expectation you can directly write variance expectation of x minus expectation of y. Okay, and now I'm coming to the x by y. So I'm not clear how to calculate this expectation of x by y. So this is a simply function, right? X by y can be also written in the form of gx, right? Gx, or no, this can't be written in the form that I need to think of. I have not went through this. Like, have you got any questions related to x upon y, or you're just asking for?
No, sir, I have not come across in activity questions. But point is that we can get this kind of question. Okay, sir. While exploring for ex by y, you also explore for variance of x by y. Okay, sir.
I'm getting.
Thank you, sir. Yeah.
So yeah, so for this I'm not sure. I'll just have to read upon this one.
Just one quick question on x minus y. Is there some place where we can go and see how it is calculated? That is variance of x minus y.
Okay, variance of x minus y, right? See, how generally you calculate the variance? See, for example, if you have the variance, you have to calculate the variance of minus y. What generally you write? This is similar to variance of y. Why? Because generally, if you have
minus 1 square is what you are going to do.
Yeah, minus 1. If you have to calculate the variance of ay, you write it as a square variance of y, right?
Correct.
So for minus 1, we are just squaring that.
So variance of x minus y is equal to variance of x minus variance of y, is it?
Yeah, variance of y 1 ka whole square, variance of y.
That is only if they're independent, right?
Yeah. No.
I don't think this will hold good if it is.
Yes, sir. If it's independent only, then only it is true.
Yeah. Correct. So expectation can hold for anything, but variance will hold for only independent thing. Am I clear? Expectation will hold. Expectation x plus y can hold for anything, for independent, dependent, everything. But expectation, this won't hold. This x multiply thing won't hold, but the addition will hold for everything, for the expectation. So the variance, it should be independent. And if you have to write this expectation of exy as e of x into e of y, then x and y should be independent. Am I clear?
Yeah.
Oh, thank you.
Thank you.
So always in the case of var x minus y will always be var x plus var y if they are independent, right?
Yeah.
In every case. Okay.
Yeah. Every time you have to do the summation. Okay.
Sir, in the video 3 or so, sir explained how to calculate the collab and all like that. So if we are having some random data or information has been given in that one, can we get some understanding and idea about these ones what you are explaining, sir? Like expectation, variance and all like that.
Okay, so
sir, what you told that variance can only hold for independent variable.
No, that variance can hold for anything. I'm just telling, if you are having x minus y or x plus y, and if you have to write that variance of x plus y as variance of x plus variance of y, that will hold for independent thing. But for the expectation, it will hold for any all the cases. Okay. Yeah. So what you were asking about the Python thing, collab, right? What you were asking? Can you?
Anyway, we are coming now, sir. Let it be in a sequential manner itself, sir. Thank you.
Okay. So for the first, already 34 minutes has passed. We are just in the first. So I don't think so. So the
sir, I have problem on question 5 and 6.
Okay. So 5 and 6.
And one short thing that the above question number 4. That is a binomial distribution, right? And the expectation is NP.
Yeah, you can solve this as not as see. This is a. Why are you solving as NP?
Because I thought that mean and expectation are same, and it's a binomial distribution.
It's a binomial with probability 1/4. That is fine.
Yes.
Okay, so you can calculate and check whether. I don't think so you'll get the same answer.
And no, sir,
this
but
is the equation for the binomial distribution.
I am taking n as 4, then I get the same answer. But if I take n as 5, then I didn't get the answer.
N is 4, right? In this case, I mean,
you
you
can
can
only
see the
get
equation. It's NCX.
according to the
N
code,
is 4 in this
according
case.
according to the equation, whatever has been written, n should be equals to 4. Then you will get, I guess. But if you're taking all this 5 condition, then you'll not get, right?
Why, sir? Because from the equation we can clearly see that n is 4, but here is 0, 1, 2, 3, 4. It becomes 5, na?
That's the value which X can
That's
take.
just the value of random variable, right?
It
Yes,
takes
it's
the
just
value from
which
the
random
0.
variable can take. Yes.
Okay.
Yeah, these are the value of random variable.
Okay, I got. Thank you, sir. Please continue with 5 and 6. Sir.
Yeah. So 5 is what? 5 we have to, maybe you would be doing some calculation mistake, but I don't think so there is any conceptual issue in this problem. So suppose that the game is to be played with a single pair die. Okay. In the game, the player wins 100 rupees. If 3 turns up, right? For the 3, so you have to just if you are getting 3, you'll get 100 rupees, right? So 3 into 100, that is fine. And 150 if the 5 turns up, so 5 into 150, and loses 160 if 4 turns up. So 160 minus 160 into 4, right? And while the player neither wins or loses, if any, so you just have to add. So 300 plus, what is that? 150 into 5 is 750. How is that? 1050 minus 640 would be the answer.
No, it turns out it isn't actually.
We don't have to multiply it by 3 and 5 and 4, right?
We don't have to multiply by 3 and 5 and 6, 4, I guess. It is just that probability of getting 3, which is nothing but 1 by 6.
Yeah. Sorry. Okay. So you just have to calculate with the probability of getting 3 and 5, right?
Yeah.
So
we should multiply with 1 by 6.
1 upon 6, what is that? 100 into 1 upon 6, 150 into 1 upon 6, and then minus 160 upon 1 upon 6. You'll get the value. You can just do that.
Yeah, 15, right, sir.
Yeah.
Can you just repeat what happened there?
Yeah, I was in mistake in that loss. I didn't saw that loss thing.
So wherever you get the loss, just do multiply with the minus. Okay. So you can do that similarly. I guess we'll be having problem.
On the 5th one, can you just repeat what just happened? Sorry, I missed out the part.
Okay. So here the probability of getting 3 is what? 1 upon 6, right? And you are getting, so you are winning 100 rupees when you are throwing a dice and you are getting 3. So this is a simple casino problem. You are getting 100 rupees if you are getting 3, right? You are getting 150 if you are getting 5. And if you are getting 4, you are losing 160. And rest of the other cases, you are not losing nor gaining anything, right? So what you have to calculate? You have to calculate the expected won, how much money you have won. So what you will do? So 100 into the probability of getting 3. The probability of getting 3 is what? 1 upon 6, right? So what you have to do? 100
we do not
into
multiply by 3, is it?
You don't have to multiply by 3. You don't have to multiply with the probability. So how generally calculate the expectation? You have to multiply with the probability according to that 3, right? So the probability of getting 3 is what? 1 upon 6. We're not just...
Okay, yeah. The one of the discrete function. Okay.
Yeah. So similarly, you have to multiply the 150 into the probability of getting 5. Similarly, there is a loss of 160. So you have to multiply minus 160 into probability of getting 4.
Got it. Thank you.
Yeah. So similarly, you'll do with the 6th
What
question.
about bias, sir? Bias. No, question number 6. Bias.
Sir, bias one, it is difficult.
Okay. So suppose that a game is to be played.
Is given, na?
So probability would be given for all the cases, right? The number from 2 to 6 are equally likely. Okay. So 2 to 6 is equally likely. That is what? 2. So you can just take it from 2 to 6, we are getting the probability of x, right? So the x plus x plus x plus x plus x plus y, right? Equals to 1. But the number 1 is thrice as time. So, okay. So you can just do it like this. So the probability of getting 2 to 6. So 2 to 6 is what? X. So 1, 2, 3, 4, 5, 6. So all these are x. So 5x. And for 1, what has been written? What is that? But 1 is thrice as likely as. So this is 3x. Okay. This is 3x equals to 1. Right. These are basic properties of the probability. So x equals to 1. X equals to 1 upon 8. So probability of getting 2 is 1 upon 8, 3 is 1 upon 8, 4 is 1 upon 8, 5 is 1 upon 8, 6 is 1 upon 8. But the probability of getting 1 is what? 3 upon 8, because it's the 3x. Are you getting my point?
Yes, sir.
Yeah. So the probability you are not now you have the probability value, right? For all the possible cases. So for the 2, you are having the probability as 1 upon 8. For 4, 3, 4, 5, 6 also. And for this, you have 3 upon 8. And for all this, 1 upon 8. So now what you have to calculate? So you have to calculate the same thing now. So whatever the probability earlier you will get, earlier you were multiplying multiplying with the probability value at 1 upon 6 every time. Now you have to see that, right? For example, for 100, 3. What the probability of getting 3 is? 1 upon 8, right? So you have to multiply 100 into 1 upon 8.
Correct, sir.
So similarly for 5, 1 upon 8. 4, 1 upon 8. And you just have to multiply with, here for the losses, you have to multiply with minus 160. You'll get the value. Is it fine?
Sir, how you
why
can
did
you
you say
move
one?
to the last note?
Sir, why
Okay.
did you say to multiply?
How you got that probability of probability at 1 upon 8 and 3 upon 8?
How did we get that? This is what you are asking. Okay. So, okay, I'll just erase it and I'll try to explain it more. Okay.
Slightly clean.
Okay. Yeah. Yeah. So the probability of the dice, what are the possible cases that we can get if you're throwing a dice? 1, 2, 3, 4, 5, and 6. Right? This is what we can get. Okay.
Yes.
Okay, so this has been asked. This is a biased one. Biased one means the probability is not same for all the cases. Okay, so the numbers from 2 to 6 are equally likely to land up. So the matlab, those from 2 to 6.
Sir, we can go in Hindi.
Okay, but many of the people will not understand Hindi now. So okay, so I'll just explain this thing in Hindi. 2 से 6 तक का probability same है. From 2 to 6, the probability is same. That means what we can assume the probability of getting 2 as x. So we already have assumed the probability of getting 2 is x. So सबका same होगा. 3 का भी x होगा, इसका भी x होगा, इसका भी x. Okay. Now what has been written here? But number 1 is thrice as likely to land up. मतलब इसका जो probability है, the probability of getting 1 is thrice as the other. Means the probability of getting 1 is 3x, right?
Yes, sir.
What is the basic property of the probability? That the summation of all the probability value should equal to 1. So we'll do the summation. We'll get the value of x as 1 upon 8. Okay. 5x plus 3x. So you have got the probability value. Yes, now sir. You don't have to do anything. Like,
sir, but I'm getting 0, sir, actually.
Okay. You are getting 0. So 100 into 1 upon 8, what is that? Can somebody tell me 100 into 1 upon 8? Next is what? Next is what? Next.
So 25 by 2.
1 into 1 x. And then 160 upon 1 upon x. So you're getting 0. This is not 0, yeah. This is 250. And this is 160. So 90 upon 8 you'll get.
Sir,
90 upon 8.
By 4.
90 upon 8. This is
11.25.
11.25. Yeah, this is this one. Okay. So this is done. So first lecture is done. I don't think so there is any issue in this. You just have to calculate, just put the value of x, you'll get the probability value, just multiply all the expected outcome, you'll get the expected value. Okay. I'll move to the second one. Second lecture is what? So you just have to, these are properties, basic properties of the. So the first, which of the following options are correct? I don't think so there is an issue. This is incorrect. This is also incorrect. The second one is correct. Okay. Yeah, the first one is correct. The second, does anybody has any problem? Just raise your hand or you can just speak out. Just unmute and speak out. And the second question is, yeah. Do you have any issue? Okay. So suppose that the random variable x takes up 2, 3, 4. The expectation is 3.4. The probability of getting x equals to 2 and x equals to 3 is same. Find the value of probability of x equals. Yeah. So what you can do is, you can assume this probability of x equals to 2 as what? X. So similarly, the expectation, the probability of getting x equals to 3 is also x. Yeah. So somebody has raised his hand. You can unmute yourself and you can say, Ramakant.
Sir, actually, that inequality, I have a question. So, shall I ask after this activities, or would you permit me to speak now?
Yeah, you can ask in between also. You can ask in the end also after just completing the activity question. You can ask.
Okay. Okay, sir. After this, I will ask.
Okay. So yeah. So the second is yeah. So you already have the value of the x. You have the probability value. What you can do is you can just assume this probability as x, this is also x. You can assume this as y. So 2x plus y is 1 because this is the basic properties of the probability. One equation. Second equation you can get with 2 into x plus 3 into x plus 4 into y equals to 2 and 4. So you just have to solve the two equations. You'll get the value of x and y and just put the value of x, y here. Have you got the point, or should I write it?
Can you write it, please? Because I tried, I seem to have made mistakes.
Okay, I'll write it down. Okay, so the probability of getting x equals to 2, if we can assume as x equals to 3 also we can assume s because both are same. X equals to 4 we have to calculate, that we will assume as y. So the probability values, so 2x plus y would be 1, right? This is the basic properties of the probability, that the summation of all the probability value will be equal to 1.
Can I interrupt? Sorry. Can we write a probability of x is equal to 4 as 1 minus 2t, 1 minus 2x?
Yeah, this is what y equals to 1 minus 2x.
Yeah.
Right?
Yeah.
So this is also, yeah, so that makes the question more simpler, right? So now we are having this x, this is 1 minus 2x, right?
Yeah.
So now the expected value you already have, the expected value is 3.4.
3.4.
How then will you calculate the expected? So 2 into 2x, 2x,
3x.
plus 3 into x, 3x, plus 4 into 1 minus 2x equals to 3.4. So you'll get the value of x, and you can just write it 1 minus 2x is y. You just have to calculate the y value, right? You'll get the y. Have you got the point? Should I solve it? Okay.
Please continue.
Okay. So it's done. And after we'll move to the next question. What is that? This simple addition subtraction. I don't think there is any issue in this. If you're having any issue, you can ask. The third fourth question is pretty simple. 5, you just have to solve this equation. So what is this? Y equals to, you have to calculate the expectation of y. That is what we have to calculate. The expectation of y, and expectation of y is what? Expectation of y was x minus 1 and x minus 2. You just have to solve this. So how generally solve x square? X square minus 2x minus x minus 3x plus 2, right? So the expectation in this, you have to calculate the expectation of x square minus 3 expectation of x plus 2. The expectation of any constant is what? 2 only. So this you have to solve from this equation. How will you calculate this? You can calculate x square into the probability of getting this x equals to x. And you have to do the summation of all the values. Yeah.
I think we can simply put the value of x in the expression x minus 1 and x minus 2, and that will be much easier.
Yeah, correct. That is also one.
Yeah, here itself we can put the value and we can get the.
Correct. Yeah, this is also one method. I'm just going with the flow, with the basic approach that if somebody has just read for the first time, he can solve with this approach, right? Okay, so I'll move to the next one. What is the next one? Okay, so this question you can solve, right? How will you get the value of k? Somebody can say me, how will you get the value of k?
So we can add the marginals and they have to be equal to 1.
You can just add all the probability and equate it to 1. Do not take marginal or anything, because the probability of whatever the multiple variable you are having, whatever the how many whatever the number of multiple variables are there, you'll get the summation of all the probability value as 1, right? So you just have to do the summation of all these values. You'll get the value of k, right? I was just asking to calculate the value of k. Okay.
0.05.
Okay. So k. Okay. So whatever the value you are getting, like for example, you are getting k equal to alpha. Now, so you are having all the values of alpha, like all the values of all the probability value. Now you are having. Now you have to calculate the expectation of x. Expectation of x. How then will you calculate? You calculate the expectation of x as x multiplied with the probability that x equals to x, right? So how do you write this? This is what this. The expectation of x you have to calculate. This is what? X into probability of x equals to x. That you have to do the summation. Okay. So here you have to calculate the marginal distribution. So this is what I guess he was trying to say. So you can just calculate the marginal distribution of x. So how do you do that? X equals to 1. X equals to 1 means this, you are fixing x equals to 1 and do the summation for all the values of y. So fixing the x equals to 1, while doing the summation, we have got 6k. Similarly, fixing the value of x equals to 2, we have got 2k. Fixing the value equals to 3, we'll get as
12K.
12k. Okay, so now you are having the probability value for all the x, and you have and you are also having the x value. Just multiply, do the summation, you'll get the expected value of x. Anybody any issue? You can ask me how to calculate the margin. Yeah.
Sir, here you are saying that, let us say, after finding the value of k, I will multiply by x is equal to 1. So 1 into that k, the value of k, whatever I have got, let us say 1 by 2. So 1 by 2 plus twice of 1 by 2 plus thrice of 1 by 2, right?
What?
Let us say k, I got 1 by 2.
Whatever, k, let it be k itself.
Okay, k itself. So x is equal to 1, then I will get 1 into, let us say k plus 1 into 2k, then 1 into 3k. That will be x is equal to 1 value, total summation of all these three.
Like 5k you got into 1 plus. So what you are doing is you have to get the margin. Please see what is there. You have this x equals to 1, x equals to 2, x equals to 3, right?
Yes, sir.
So how generally you calculate the expectation of x? You generally, simple formula x, you have to get the outcomes. So what are the outcomes here? 1, 2, 3, right? And according to the 1, 2, 3, you have to get the probability value. X equals to x. That means you have to get 1 into probability such that x equals to 1. What is this value? This value you can get from here, right? X equals to 1. Fixing the value of x equals to 1 and do the summation for all the value of y, right? So whatever the value you were having here, do the summation. You have got how much? 6k, right? Here it was 3k, here it was 2k, here it was 3k. So you got 6k, right? So 1 into 6k. Similarly, for x equals to 2, you can write 2 into whatever the probability value you get. You will get around 2k, right? So 2k. Similarly, for 3 into whatever 12k, I guess. So you can do the summation, you'll get the value. Is it fine?
Yes, sir. Yes, sir.
Yes, sir.
Oh. Okay. So I'll move to the next question. So we have already passed 1 hour. Okay. And similarly, if you have to calculate the expectation of y, you can calculate the expectation of y, and you can calculate the expectation of x plus y also. Okay. Okay. So
it will be simple addition after calculating.
Yeah, you can do this. Yeah, you can do the addition. Yeah, you can do the addition because asking for the expectation. The addition and expectation is possible anywhere, whether it's independent or dependent doesn't matter. Okay. Now we are moving to the next question. Here also you already have everything. Now you have to calculate the expectation of z, and this is x square. Okay, so just be correct. This is not x2. This is x square. So you have to calculate the expectation of x square plus 3xy. Just see that. I guess this is the independent one. How will you do that? How will you know? Okay, can somebody say me how will you know this is independent or dependent?
Sir, marginal is equals to
sums up
point is equals to marginal into.
Sir.
So what you will do? Just calculate the marginal distribution of all the cases. Yeah. Okay, for all the x and all the y. So like for example, what you will get here? 0.25 you will get here, right?
Yeah.
For this, what you will get? You will get 0.4. So 0.4 into 0.4, 0.4 into 0.25, you will get 0.1, right?
Yeah.
Similarly, for all the cases, you can see for all the, if you just write the what you can say, the margin value of the x and marginal distribution of y, you'll get all the values. Just have to multiply and get whether for all the cases. Just remember, for all the cases, it should be like the product value should be there, right? If for even for the one cases, the product value we are not getting in this box in the table, you can't say it's independent. Okay, right? So for all the cases, it's a compulsory thing. It's not a sufficient. It's a compulsory thing that for all the cases, the product, whatever we are doing, the product of marginal distribution of x and marginal distribution of y, we should get the value in the table for all the cases. Then only you can say it's an independent one. And if you are getting this, you can directly write this expectation of x, y as expectation of x into expectation of y, right? Have you got the point, or should I repeat it?
A little slow, perhaps.
Okay.
I'm understanding it as you are trying to actually say the conditional and the joint should be the same. So the marginal has to be, if you divide it, divide the probability by marginal, joint by marginal.
No. Don't go with marginal. See, don't go with the conditional. Just calculate fixing the value of x equals to 0. If you'll fix the value of x equals to 0 and do the summation for all the y, you'll get the marginal distribution of x equals to 0, right? You'll get something? Okay.
Yes.
Similarly, you'll do for fixing the y equals to 0, do the summation for all the x, you'll get the marginal distribution for y equals to 0, right?
Yes.
Okay. So what are the marginal distribution of x equals to 0 and marginal distribution of y equals to 0? If you are doing the product and if you are getting the value here as same as the product for all the cases, not for only one cases, for all the 6 cases. If you're getting the product as same as whatever the written in the box, you can say this is an independent one.
Yeah.
Okay. Even for one cases, it doesn't come. If it doesn't matches your value or the multiple random variable probability value. Okay. Even for the one cases, if that is not equal, you can't say. So it's a compulsory thing to get all the value as a product of marginal distribution of x and y. Okay. So I guess for one case I can see this happening. For the other cases also it will happen. If that happens, you can directly write the expectation of xy as what? Expectation of x into expectation of y, right?
Yeah.
So
and the x squared, sir? Then what about x squared?
That you have to calculate. How will you calculate x square? So you can just write that x square into the marginal distribution of x. Like for example, a marginal distribution of x. Like for example, x is what? X is 0. So for 0, you don't have to write anything. 0 square will get cancelled. Okay. For x equals to 1 into probability of x equals to 1. And plus 1, 2. 2 square is 4. Okay.
And probability x is equal to 2.
So just do the summation, you'll get the probability of x square, the expectation of x square. Right?
Okay. Sir, in this case, I checked, I think they're all independent. So we can do what you just mentioned, that it would be expectation of x into expectation of y.
Right. Then you can do
if it wasn't, then what would we do?
Then see.
Sir, this x square, can you please repeat?
You can find xy. Xy is the another random variable.
Your voice was not clear. Can somebody, if somebody has understood that, can somebody repeat that? Or what he was asking?
Sir, x square once, can you please repeat what you said?
Okay. So one thing is, expectation of x square you can calculate as how generally, I told you in the starting itself, whatever the function you have been asked, like for example, some gx. Gx is what here? For us, it's x square, right? So what you will write, you just have to multiply this gx into the probability of getting this gx. Like for example, the probability of gx equals to whatever the value you are having. For example, here, what function we were having? X square into probability of getting x equals to x. And do the summation of all the values. Right? So here, we were having x equals to 0, 1, and 2. So for 0, this got cancelled. For 1, we'll write 1 into probability of x equals to 1 plus for 2, what we can write? Probability of x equals to 2. Multiply this 4, right? So you'll get the value. Are you getting my point?
Yes, sir.
So in between somebody was asking, so he was asking some questions. Can you repeat that?
Does it hold even if they are not independent? Whatever you
Yeah, sir, I was asking if it wasn't independent, then how would we go about it?
It will hold for every time. X square.
Oh, fantastic. Okay.
Not this one, xy. Only that x square will hold every time, because x and x is what? Like it's almost same only, right? But
the question was more about xy because
so for xy, you have to write it like this: xy, x into y, and then you have to multiply it with this xy, and then do the summation. If this is not independent, if this is a dependent, you have to calculate like this. If this is an independent, you can directly multiply x into y. Are you getting my point?
The generic one would be sigma.
Okay, I'll write it. Okay. So for the independent,
can you take the same one table as a assuming a dependent one and do the calculation?
Okay.
That will be easier.
Okay. So for the independent one, E of xy is E of x into E of y. Okay, and if this is not independent, how will you do this? Expectation of xy is what? X into y into this, and do the summation. Like for example, I'll tell you here, if this was not an independent, if this was not an independent one, if this was an independent, how will you do that? Okay, so here you can do xy, what value you can take? X equals to 0, y equals to 0. So 0. X equals to 1, y equals to, so this all will get excluded. So now you have to do x equals to 1, y equals to 1. X equals to 1, you can write, where is that? X equals to 1 into 1, and then f of xy 1, 1. Okay, what is that fx2 of 1, 1? 1, 1 is this one, 0.30, right? So you just write 0.3 plus x equals to 2, y equals to 1. So similarly, all the cases you have to take, right? So plus 2 into 1, and then you have to get fxy of 2y, 2, 1. Similarly, for all the cases you have to calculate and do the summation, you'll get the expected value of xy. Have you got the point?
But there are only, because zeros knock out all of them, it's only one and one that are valid, right?
Yeah, so zero, whenever there is a 0, it will get excluded itself. So the calculation part will become simple whenever you are having x or y as 0. Okay. So I'll move to the next part. So we're done.
Just to ask that since joint distribution is already given, can't we just substitute the value of x and y in the function and then use it? Wouldn't that be much easier?
What? Expectation of?
Since we already have the joint distribution of the given in the question, can't we just substitute the values of x and y in the equation and then using the joint probability simply find the solution? That would be much easier in this case.
We are doing the same thing, right? We are writing the probability value from the table itself, and this x and y we are also taking from the table. So I guess you're saying the same thing, huh? Or you're saying some different approach.
So I'm saying that substitute the value of x and y in the entire equation, x square plus 3xy, because we already have the joint.
Okay. That can be one method. Okay, that can be one method.
Yes.
Yeah. Fine. Yeah. But this is a basic approach. Whenever you are getting some questions, you have to like this. You should go with this approach. This is a pretty simple one. Okay. It will take a bit time, but I don't know. I didn't solve with those approach, whatever you're saying, but you'll get the correct answer. That is pure pakka. So, but every time I solve, like I didn't solve, but I'll solve with this approach also. It will take a time, but the method is correct for you. Those methods are also correct. But yeah, okay. So I'll move to the next part. So till now, if somebody is having any issue, you can ask. We'll move to the third part. The third part is proper coding stuff. So if somebody is having any issue, you can directly approach me, because now if I'm going to solve, because so somebody is asking the doubts related to this. Can you ask now?
Yeah, the thing is, we are expected to do something on this coding part wherein it has been given to us in extra activity kind of thing.
Yeah.
So we need to check the same aspects what we have taught. Or sir, in the second week also he explained, sir, changing the probabilities and all like that. So shall we?
There used to be some session on the extra activities, but I don't know till now it has happened or not. But I'll just ask the team if they can have one session on the extra activity, right?
Today is the last day for third extra activity, sir.
Oh, okay. But I was not aware of that.
No, it's in place till 27th. 27th is the last one.
No, for extra activity is 25th.
Today it's also. Can you change the date, sir?
No, that is sorry. I'm really sorry. That is not in our hands. Due to the dates and all. We are already very late this time because of the event and all.
For extra activity 3, right? It is 27th.
Sir.
Yeah.
We will get this programming type of question in quiz.
No, you will not. No, you'll not get any programming stuff, because the programming stuff are going to this just Andrew sir gave you the list. Okay, it's not proper coding, because many of you are not familiar with the Python itself. Many of you have done just one basic course of the Python. So don't worry about that. There are so many other courses so that you'll get pro in coding stuff and all. There are other courses.
But that counts for the bonus marks, no?
Yeah, this is just a bonus marks thing. If somebody already knows or somebody just want to give some more time and all, he can get some basic marks. Okay. And that is not compulsory for everyone to do that. But okay, if you're doing it, that's really awesome.
But somebody was telling that it is.
सर मेरा तो 50 से 60% भरोसा bonus marks चाहिए.
Okay, just some news. Just looking at it, it is also 27. So we don't have to fret about it at this stage. Probably if a session can be arranged, it will be really helpful.
Where is 27? It is still 25th only, no?
Did you check the site now?
No, extra activity has been changed.
Did you check the site
deadline
now?
is 27th.
Yeah,
It
I
is now
just checked
27.
right now.
Yeah. Kindly check the site.
Yeah, I do that.
Okay, so I'll just ask the team first. Okay. Yeah.
Sir, that
Sir,
question
in
about
this particular activity, actually, if we open that one, lucky to open that collab kind of thing, and if you change the probabilities, like it has given 1 by 2, 1 by 2 kind of thing. If you change to 1 by 3 or 1 by our requirements kind of thing, and at the bottom actually, if you run the code, the bottom numbers will be changing. So we can understand clearly the variance and other aspects very clearly.
Yeah.
For that's why this video has been done, sir. So that could be helpful for us to in further aspects.
Yeah, I'll just ask the team if they can arrange some session, because you already, again, I guess day after tomorrow you have the session related to whole week. There's like, because of the event and all, the time, like the sessions and all has been constant. Every day you are having so many sessions and all. So you need to see that whether you can arrange. I'll be asking when you do some extra. So we'll try to do some sessions, extra session 1 or 2 related to the Python. If somebody from the Python can take this session, we have the person who can take, but I'll just ask. I can just ask him whether he's available or not. Okay, we can't make sure about that.
Sir, can you make this quiz slightly this time more slightly easy?
It's already been made. The paper and all has been already made. The question is pretty simple. Don't worry about that. Just
Sir, about the collab, it is written that if you guys are interested in technical assistance, our technical assistants will do the necessary calculation.
So what you can do, see, if somebody is having issue in the Python thing, you can ask me. I'll try to solve if I'll be like able to, because I generally take some courses in ML also. So maybe if I'll be able to do this, I'll help you. Otherwise, I can just refer some other person also. Will be able to help you. Okay. So
but you need to have a session, no?
Yeah.
Are you planning for that one?
We are not sure. Like I'll just ask my team whether somebody is available, because what happened after the event, everybody is having session every day. So if he's free, then one will be able to take that, right?
Yeah.
Because in the last week we are not having much sessions because of the events and all. So this week everybody is packed with the session. Even the Python guys or the ML guys are all packed with the session. Okay.
Sir, the activities we are talking about, that there it is written that week 0 activity 3.
Not week 0 activity 3. What is that?
That activity we have to submit on 27th, right?
No, activity 3.2 is already done. 3.3 is the one which we need to submit it.
There it is written like week 0 activity 3.
Yeah. That extra bonus activity, right? So basically what I saw was like there is ton of materials from week 0, right? So slowly they are putting this with a later deadlines. So once, I think if you go to it, you can see, I think they refer to some video also.
Okay. But not much information is there in the video. Means what we need to do with the week 3 kind of thing.
No. There is around 5 to 6 examples are there in the week 0 video. You can choose one of them and modify, and you can use that as your own problem and put up a code there.
Up to what I understood was that maybe I'm wrong. Maybe my understanding was wrong. What they're expecting was either take one of those 6 or 7 examples which they give and predict it. So to put it in a simple words, what they're telling is like we know once we toss the coin, there's an equal probability of head and tail, right? So what they're doing is we know this as 0.5 for head or tail. But in that programming, what they're doing is they're taking like 1,000 times they're tossing a coin and counting all the times they got head and dividing it, like adding everything. So it will be closer approximation to 0.5 itself. So I think that's what
yeah,
they're
that
asking
Monte
in that.
Carlo simulation.
Yeah,
We
that's
need
all
to
they're asking in
do
that.
that.
Yeah.
Yeah.
And the better
Whenever you will just
when the
increase
coin
the
is biased.
whenever you will just increase the number of data, it will
I
be
think
closer to
that
0.5.
simulation part is been discussed in week 0.
Okay.
Sir,
So okay, we'll move to the next video, man. Okay, we'll
Yes,
discuss it
sir.
later.
Yes, sir. Let us move to next video, sir.
Because I have to go by 8 itself. Like I'm
Yes,
leaving. I'm leaving. Like I'm in the
sir.
Chennai. I'll be leaving to tomorrow morning. So I have to. I'll be taking the session till 8 only. So I'll just move to the fourth week.
yes,
Fourth.
sir. Continue.
Okay.
Sir, actually, will you be taking that those inequalities inside this?
Yeah,
So
yeah.
I will,
After this fourth, we're just
Okay,
about to reach. Okay.
Okay.
So the fourth week, I'm saying fourth lecture, we have been taught about like we have understood about the variance and the standard deviation. Standard deviation is nothing the root of the variance, and variance you already I already told you how to calculate the variance. So it's a pretty simple formula for the variance. The variance is simply the spreadness of the data, how the data has been spreaded. Like I told you that regarding the marks of the marks of one subject, like for the maths in the class. Okay. So if you are having the expectation, that the average value and the spreadness of the data, we can say regarding more like with the expectation also we can say regarding the marks, like how does that class perform. But if you are having the spreadness of the data, that will make us a bit closer to a perfect that will make us closer to the exact data, right? With the help of only two data sets, the variance and the expectation or the spreadness of the expectation, we can say a more closer value of a larger data set. Okay, the variance you can directly calculate. You can variance can be calculated with the expectation of x square minus the mu square. Okay, so this is a basic formula. Now we'll go to the some questions where to, and the standard deviation is simply the root of this. So say sigma square is the variance, and the standard deviation of x is what? Sigma. Okay. So we'll move to the question. So if the probability that the leader will earn, it is in the probabilities have been given, the rupees also given, and similarly you can calculate the variance. You can just the probability value you already have. The calculate the expectation x square, and then calculate this mean value. Just do the subtraction, you get the value. Okay. You don't have to do anything. In here also, you already have the variance of 3x plus 4. That means what? The 9 into variance of x is equals to 144. You'll get the standard deviation. Calculate the variance of x. Just do the square root of that, and you'll get the standard deviation. Now, if x and y are independent, so if you are independent, that is what we were talking. If you have to, if the x and y are independent, you can directly write this variance x minus y as what? X variance of x plus variance of y. This is what? 9 plus 9 is 18.
Can I pause you? Can I pause you a little bit for the second problem to clarify? It is variance of 3x plus variance of 4, which is normally 4 itself, right?
Variance of
9x plus
4 is 0, right?
Oh, sorry.
If you are having the value, all the values. Okay.
Its expected value of 4 is supposed to be 4. Yeah, right. Sorry.
So now we'll move to the fourth one. Fourth one is basic. Fourth is what you have already the expectation of what? Expectation of x. You can just assume that expectation of x is 6 lakhs. Standard deviation is 40,000. Now you have to calculate the expectation of 0.2x. How will you do that? You'll just calculate 0.2 into 0.2 and the expectation of x, and then take the root. You'll get the standard deviation of that.
Sir.
Yeah.
Sir, can you please solve this question, fourth one?
Yes.
Okay,
Here I have a doubt, sir.
Okay.
Yeah, please solve, then I will ask you. Please solve, sir. Yes.
So what was that? Expectation of x is what? 6 lakhs, right?
6 lakhs.
Standard deviation of x is what?
40,000.
So what has been asked to calculate? That's the annual salary of the employees random rate of the expected. Okay. The employee invests 20% of the amount. And now you have to, so you can just assume this y as what? 0.2% of x, right? This is 20% only. Now you have to calculate, find the standard deviation of the amount invested. So you have to calculate the standard deviation of this. You have to calculate the standard deviation of this. How will you calculate the standard deviation of anything? So you just have to calculate the variance of y. If you are having the variance of y, you can take the root of variance, you will get the standard deviation of y. How will you do that? So variance, you have to calculate the variance of 0.2x. Variance of 0.2x is what? 0.2 ka whole square into variance of x. Variance of x is what? The square of this, right? So 0.2 into 0.2 into variance of x. Variance of x is 40k into 40k. You'll get the value and take the square root.
So why are we not just multiplying the standard deviation by 0.2?
Yeah.
So see. What?
We can actually directly straight up multiply the standard deviation with 0.2, right?
So there it doesn't ask 20% of the amount, right? So 20% x I'm taking it as 6 lakhs, right?
So
Yeah, but
that
the
is the
standard deviation,
expectation, sir.
yeah,
Expectation is 6 lakhs given.
the standard
so we
deviation is
find the
40,000.
original amount.
If the standard deviation is 40,000, this I mean the variance is 40. Okay, so standard deviation can be found out, right?
Expectation is 6 lakhs. Standard deviation is 40 lakhs, right?
Yeah.
40,000.
Okay. What do you have to calculate? Just I thought y equals to 0.2x. 0.2x means what? 20% of the x, right? Have you got the point?
So are we calculating the 20% of the expected amount or 20% of the original amount?
20% of the original amount.
So original amount, so we need to calculate, right?
See.
Sir,
Okay.
sir,
Wait, 1 second. 1 second. 0.2x, just whatever I'm saying, please listen 1 second and then you can counter me. So y equals to 0.2x. Y I just assume as 0.2x. 0.2x means 20% of the whatever the money we are having. Okay, so 20% of this is y. Now I have to calculate this has been asked, they have asked me to calculate, where is that, man? Okay. So they have been asked to invest 20% of the amount, right? So find the standard deviation of the amount invested. What is the amount invested? 0.2%, 20% of x, that is 0.2x, right? Okay. 0.2x, y equals to. Now you have to calculate the standard deviation of y. How will you calculate the standard deviation of y? You have to calculate the variance of y and then take the square root, right? Variance of y, how will you calculate? Put y equals to 0.2x. Okay. How will you do that? 0.2 ka whole square, then variance of x. How will you calculate the variance of x? If you have variance of x can be calculated as square of standard deviation of x. Standard deviation of x has been given, right? What is that? 40k. So 40k into 40k.
So why are we doing 0.2 squares?
Okay, and then take the square root. So what is the value? 0.2 into 40k. What is the value we are getting? 8k.
1000.
Yeah, now so, you can ask me.
0.2 square, I can get that, sir. We are missing something in front of it, please.
Your voice is not clear. Sorry, I'm not able to hear.
So why are we doing 0.2 squares, sir?
Why are we doing 0.2
square? No, not that. Can you scroll down a bit? Yes, sir. For variance
okay.
Of
so variance of
x.
Okay. So variance of ax is a square variance of x. Okay. Variance of ax is a square into variance of x. So
yeah, that is the formula, sir. Thank you.
So this you can write down. Okay. So this is
done.
So
can't we just directly write standard deviation of y is equal to 0.2 times standard deviation of x?
What? Can you repeat that? Can we write?
Can't we write standard deviation of y is equal to 0.2 times standard deviation of x?
Yeah, you can write.
So we can just directly.
Yeah, 0.2 into 40k is 8k. Okay. So yeah, now somebody is asking something like why?
Referring back to the last question, if we can directly write it, standard deviation of y is equal to 0.2 standard deviation of x. Why do we do all this complicated?
This I just shown you how we are getting, like how are we getting from here. So this 6 lakhs is not of use. Okay.
Is it a coincidence or it is always right? It's always right.
Yeah. So see, y point to this has like this was supposed to be right here because we were doing the square root. We were doing the square and then taking the square root of 0.2, right? That's why we are getting in the end at square root of 0.2 ka whole square, and then in the end we are getting 0.2.
Yes. Okay.
Yeah.
Thank
So
you,
that's
sir.
why for this time it was correct. Every time it will correct, but
every time it is correct, you know.
Yeah, it will every time it will correct, but depends on the what do you say? Like equation whatever you are getting. Okay. It depends on the equation. So here the equation was such that we in the end we got standard deviation of y equals to 0.2 of standard deviation. Okay.
Sir, could you explain question 3 once again?
Question 3. So question 3 is what? So x and y are independent. If x and y are independent, then variance of x minus y is what? Variance of x minus y. So variance of x minus y. This we can write it like this: variance of x plus minus of whole square variance of y. Can we write this?
Yes.
If x and y are independent. So
yes.
Variance of x is what? 9 plus 9 is 18. Right?
Okay. Thank you.
Okay. So we'll move to the next part. I don't think so there is anything.
Sir?
Okay. Yeah.
Coming to that salary question, my salary is basically a constant, right? So expected value will be that constant itself. So that expected value is 6 lakh, right? So in one of the example during video lecture, professor has shown that variance of a constant will always be 0. So if variance is 0, then standard deviation should always be 0. So I'm not getting this point that how come the standard deviation of salary is 50,000.
That means the salary is not a constant, right?
This salary is not constant because it's annual salary. Annual salary means all the salary every month he's getting a bonus or some other
different amount. Okay.
Yeah,
okay,
different
fair
amount.
Enough. Okay,
Yeah.
fair enough. Then let us move to next point. When you wrote that variance of x. So variance of x here, expected value of x is given. That's why someone else was also asking this question, that it is actually expected value of x, not x, right? So how to find out x?
What
when you are writing variance of x, right?
The variance of x has been given already, right? A standard deviation has been given. The variance
okay, so
is
we have to take the help of the standard deviation to compute.
Yeah. We are not using this expected value anyway.
Okay. Fine, sir.
Okay, so I'll move to the next part. What is that? Next part is okay. So 3 pair coins are tossed. Find the variance. That will x is the number of tails that you have to look the categories, like how many tails you'll get if you're throwing the 3 pair coin. Okay, and then on the basis of that you'll calculate the variance. You can do, I guess, with the simple method also because the coin is pair, so NPQ also will work here. Okay, so NPQ you already know, right? NPQ is for the binomial expression. Okay. Here also, see.
Sorry, can you say the thing about NPQ again, please?
So NPQ is the variance, like if you're having the success and failure, right?
Okay, Q being the failure, is it?
Q being 1 minus P?
Yeah, and Q is 1 minus P. Okay. What's the point? This is the variance, and the expectation is what? NQ, NP or N, right? For the binomial. So this will happen. This will occur for this also. This sixth case. Sixth case is what? Sixth case was not the binomial, but it has been described as a binomial because I equals to 1 when A occurs and I equals to 0 when it doesn't occur. And the probability of happening this is 0.6. That means what? It has been converted into binomial, means success or failure. If 1 comes, it's a success. If 0 comes, it's a failure. So coming of the getting of success is the probability of getting success is 0.6 and getting the probability of getting failure is 0.4. So how you calculate the variance? You can calculate the variance directly, right? NPQ. N is 1 here. So P into Q. P is what? 0.6 and Q is what? Failure. Probability of getting failure is 0.4. So you'll get 0.24, I guess, as the answer. So similarly, here also you can calculate the variance. With the basic approach, you can calculate the variance here. I don't think so there is any issue. Is it clear to everyone till
yes,
here?
Yes.
No, fifth problem, it's Okay, NPQ, even if I were to do the 3 into probability of success and probability of failure is what you're looking at.
Okay. This for this, I'm pretty sorry. Yeah, I'm really sorry. This will not work here. Because X is the number of tails you're getting that appears. The number of tails can be X equals to 0, 1, 2, 3. Okay, so that you have to go with the basic approach. It will not work here. Okay.
Yeah. So how do we find the variance there? We construct the joint probability and then look at it, or how is it?
Yeah, simple, like X equals to 0. X equals to 0 means you are getting 0 tails. That means head you are getting 4 head, right? 3 head you are getting. 3 head means 1 upon 2 into 1 upon 2 into 1 upon t, right? That is the probability. X equals to 1. X equals to 1 means you are getting 1 tail, 2 head, right? So what is the probability of that? That is also 1 upon 8, right?
Yeah, the probabilities for any variations is going to be 1 upon 8 because they are fair coins.
No. It will vary. X equals to 1 means 1 tail.
For 0 and 3, it will be 1 by 8, and for 1 and 2, it will be different.
It will vary. Yeah, that is correct. Because X equals to 1 means that you are getting 1 tail. 1 tail means either the tail can come in the first place, tail head, that is for 1 upon 8. Again, tail head can also come, right? Means at the second trial, the tail will come. So that is a different phenomena. For that also 1 upon 8 is the probability. Are you getting my point?
Yes.
Yeah, the position of the tails will.
Yeah.
Position of the tails can
তো ওটা
actually change.
কোথায় আছে তোমার অ্যাপোলোর বইটা?
Yeah, the position of the tails.
তাহলে ওইটা না 2022 এর।
Okay. Now you can unmute yourself and you can say.
Yeah, the position of the tail or the head can vary. That combinations can come.
Yeah.
There is only one combination in which it is not going to be a scenario where we get no tails. That is HHH.
Yeah.
Rest of them are either I get 3 or 2 or 1.
This can happen, or tail head can happen. So you can just write all the 8 combination and just count it wherever you are getting 1 tail.
I'm counting the number of heads, number of tails. Number of tails. There is one case where there are 3. There are 3 cases where there are 2, and another 3 cases where there are 3.
So for those, you can calculate the probability. You can just multiply it to get the the expectation, and then you can calculate the expectation of x square, and then expectation of x, and then subtract it to get the
Expectation of x is coming out as 1.5.
Okay, fine.
Have
you calculated this one, expectation of x square?
Yeah, 3 into 3 heads into 3 tails into 1.8. On 2 tails, there are 3 cases. So is
okay. So the number of this is asking for number of tails, right?
Correct.
So whenever you are getting number of tails as 0, so you have to multiply 2a square. This is what you are doing, or you're not doing this? This is x square. Okay, I'll just tell you. Okay. So I'm here. So what is that? Okay, so head.
Yeah.
Head, tail, right? So I'm having 4 and 4. Okay, head, tail, head, tail, head, t. Okay. So now
that's 3. First one is 3.
No, 0, right? Number of tails we have to count.
Sorry. Yeah. 0,
this
1, 2, 1, 2, and 3.
See, so x equals to 0, what is the probability? 1 upon 8.
1 upon 8. Yeah.
X equals to 1, what is the probability? 3 upon 8, right?
Yeah.
X equals to 3, the probability is 3 upon 8, right?
Yeah.
And x equals to
x is equal to 3 is 1 upon 8.
Right?
Yeah.
Fine. Oh, so now we have to calculate the expectation of x. You can calculate directly. You can just multiply 0 into 1 upon 8, 1 into 3 upon 8, 2 into 3 upon 8, 3 into 1 upon 8. Do the summation, you'll get the expectation. Fine.
6 plus 9 plus 3 is 12 by 8, that is 1.5.
Okay, this is 1.5. Okay. Now you have to calculate the expectation of x square. How do you do that? This is cancelled. So 1 square into 3 upon 8. plus 2 chi square 4 into 3 upon x plus 3 chi square 9
Okay.
into 3.
Okay.
Okay, and then calculate this and do multiply and do the subtraction from mu square, matlab 1.5 chi square.
I'm
So you
really
get
sorry
the value.
to wasted your time. I forgot it is variance. I
No,
was
no,
looking
fine.
at expected value. My mistake. Sorry.
Okay, okay, fine, and then we'll do that. So we'll move to the next part. So I think so till here we are clear. 3.5. So here the covariance formula. Covariance is also pretty simple. Just write the formula.
Sir, could we discuss that concept, standard random variable?
Okay. Okay, I'll discuss it. Where is that? In which?
Yeah, in this 3.4 and 3.5 itself. Like lecture number 4 or 5. It is there in there.
So,
Yeah. So standardizing. See, this is a one method. So can you tell me the formula for that? How generally we do that?
Yeah, it's x minus mu, x minus
What?
mu divided by sigma. Means x minus mean divided by standard deviation.
If you have to change that into, if like see why generally we do that.
Correct.
If you're having some normal distribution, right, with some different mu and some different standard deviation. Okay, so see, whenever you'll go to the bigger data set and all, okay, so if you have to visualize those sort of things, I don't think so sir has taken much time to discuss this. He has just told how to do that, and I make the normal distribution as a standard deviation, standard normal deviation.
Sir had said, I'm just putting what he has said in the lecture, that a variable is called standard variable, standard random variable, when mean is 0 and standard deviation is 1, right? He has said this line. So my point is that how the mean of a variable can be 0. Say for example, I am producing a biscuit packet in my company. Say for example, right?
What company?
You take any product, sir, like biscuit or chips, you take any product, right? So my weight will always be more than 0. So how the expected value will be 0? How expected value will be 0? That is my question. And standard deviation is 1.
Okay. So if you'll consider, you can't, so theoretically you can convert all the normal distribution you can convert. From mean, you can convert the normal distribution from mu equal to 0 to standard deviation 1. All the whatever the data set you are having, all the data, whatever you are having, all plots, whatever you are, theoretically you can convert that into a standard normal distribution. Okay. But this is not regarding the practical thing. What you are thinking is, how come a company is having some product in a, like, for example, in a dollar? Like for example, any company who generally sells the product that is ranging from rupees $1 to $1,000. Okay, so if a company is there whose price generally appears to be from $1 to $1,000. Okay. Okay, so $1,000 or $100. So most of the products, whatever that company will be having, will vary between this, right? That from mu to what you already have read about the Six Sigma. If you are from some like corporate world, Six Sigma. So generally, that 95% of the cases, what will happen? Most of the cases, it will lie between, if you are having some normal plot, normal distribution, most of the product will lie from mu to what? Mu plus 4 sigma to mu minus 4 sigma, right? Most of the product will lie here. This, why we are converting this into a standard one, so that our calculation will become pretty simple. Okay. See, for example, if you're having normal distribution, you already know regarding the what is the
I think, sir, in lecture we have not talked about normal distribution. We have not reached up to that point. We are still in week 3, sir.
Okay.
Not able to catch up. We have not reached.
So mostly, see why I can whatever I know about, like in the ML also, we generally, whenever I'm having a data set, a bigger data set, generally we normalize the data set. So what we do, we generally
Sir
pick the
used
mean.
a term like transportation, sir.
What?
transportation or transformation.
Translation and scaling. He has used these two terms, translation and scaling.
Okay, scaling. Okay, transportation.
Not transportation, translation.
Okay.
Everything can be translated to 0, kind of thing.
Yeah,
Yes,
anything.
yes.
That is what I'm saying. If you are having any standard normal distribution, or you can say any distribution, you can just convert. Theoretical, you can convert that into mean equal to 0 and the standard deviation as 1, so that the calculation part will become similar. And how will you do that? That you already have the formula. Okay, that formula. But the practically, if you're asking how does that company will work, if I'm having all the prices from all the prices of the product will from 0, like will always be greater than 1. How come the mean value will be 0? So that is not we are trying to say. We are just trying to say if you are having some distribution, you can just convert those into a standard deviation, so that the calculation part will become similar. And how, see why I'm taking the normal distribution as an example. See, for example, normal distribution, you already know this is a plot, and this generally is symmetrical about the mean value, right? So if you are shifting the mean to somewhere else also, the value, whatever the calculation part you are doing, that will not change. This is what I'm trying to say. Why I'm taking normal distribution every time? With the normal distribution, the plot is very much similar. The plot is symmetrical around the mu. Mu means mean value. So whatever the mean you are taking, if you have to calculate the C, for example, you have to calculate the probability from here to here. What you will do, we'll just calculate the probability and we can just multiply it with the 2, right? Because it's a symmetric. Okay. So whenever you are having a bigger set and you want to have a calculation in a simpler way, so you can just standardize that distribution, and you'll be able to, in the calculation part, will be very much it will be very much easier for you to calculate. Okay, you can calculate with the different approach also, with the whatever the mean earlier it was having. But if you are just standardizing that into mean equals to 0 and standard deviation as 1, your part will become very simple. It's not regarding the practical aspect. This is just a theory approach to solve any distribution problem. Maybe I'm clear to you, I guess.
So I have a question.
Yeah.
Hello.
Yeah.
Sir, in this particular case of the standard random variable, where you are calculating how much is the random variable varying in terms of the standard deviation, like x minus mu divided by sigma, right, sir? So this mu, the mean, is, shouldn't we give the absolute value of the mean, because at instances where like we can also get a negative mean also. So I'm just asking, just probably a very simple question.
See, this is the equation. Like this is what? This is all the data set. X is what? X is all the point or the data set we are having.
Yeah, my question is, what if mu comes negative? What
if
are we
mu
doing?
comes mu comes negative.
Yeah.
Nothing else. You just have to see. For example, I'm having.
Should we taking the absolute value of mu or not? In this
no,
case?
no, you will not take the absolute value. Why you will not take C? When you will get mu as negative, when most of the data set are negative, right? Then only you will get the mean as negative. Are you getting my point?
Yeah. Okay.
So if all the data set, like for example, your data set are 5, minus 6, minus 7. Okay, 1 second. I'll just go somewhere. 1 second. Yeah.
Yeah, so what I was trying to say is that, say, in terms of, say, lottery problems or casino type problems, often what happens is the odds are stacked against the player, right? So the expectation value comes to be negative, else the house won't win, right? So in those cases, I'm saying, suppose we want to, yeah.
Okay, so see, I'm just trying to say, when you will get the mean value as negative, when most of the value, whatever you're having, most of the summation part of the negative would be greater than the positive value. Then only you will get the mean value as negative, right?
Sir, can you repeat this part, please?
Okay. Like for example, I'm having this 3 data sets, -5, -6, -7. So you'll get the mean value as -6, right?
Yes, of course. Yes.
Okay. So if I have to shift this minus, what we are doing here, we are just shifting -6 to 0, right?
Okay.
I'm shifting -6 to 0. How will you do that? You'll add
by adding
plus
6. Yeah.
Plus 6. You'll do the addition of plus 6, right?
Okay.
Or what you can do?
Subtracting -6 actually.
Sorry, subtracting -6 from. No, subtracting -6 from -6 will be what? That will be 0, right? -6 of -6. This will be 0. So this is our data set. See, for example, what formula we are using. This is 2. Okay. So formula, what we are just shifting this -6 to 0. How can we do that? We are using the formula x of minus mu. Mu is what? -6. What is our data set? -6 minus of -6. So we're getting to 0, right?
Yes.
Okay. So we are not doing anything with the mean. We are not taking the absolute value and all. Are you getting my point? Mean is already negative. Okay.
Got it.
Yeah. So maybe I make your point clear. So you don't have to do the absolute and all. You're just shifting the value. So everything. So why we are shifting? So that the calculation part will become simpler. That is what we are trying to.
If I take my first data point, that is -5. So it will be -5 minus of -6, right? Can you do the calculation? So it will be
okay. -5 of -6. So that will be 1.
Right. So here mean is not 0, no? Here mean is not 0. Now the modified the modified expression is 1. It is not 0, right?
We are subtracting with the mean actually. -6 is the mean, and we are subtracting -5 with the mean.
No, my x is taking 3 values: -5, -6, and -7, right, sir?
Yeah. So see, 0, 1, and from here we'll get what? -1. So now we are having that mean as 0, right? Have you got the point? We were having 3 points, right? -5, -6, -7.
Okay.
So from here you got 0, 1, -1. Overall the mean is 0, right?
Okay.
So what we are doing, we are just shifting the value. We are not doing anything else. We are just shifting. So I tried to tell you, we were having the normal distribution, the pretty simple distribution from where you can understand everything. So what is that normal distribution? Normal distribution was symmetrical value. So we are just shifting the value. Here it was mu was some constant alpha. We have just shifted. So we have just shifted this to some other value. So the graph will be same. Everything will be same. We are just shifting the value of mu, right? So for the theoretical purpose, we are doing this. I guess we are pretty. So we'll just move to the next part. If that is not clear, you can just like consult me. Like I'm having somebody like from you from stats 2 only. I got the call, but because of the event, I'm pretty busy. I was pretty busy. So tomorrow I'll be leaving for the home. After that, you can call me anytime. Okay, I'll be able to take you down.
That inequality वाला बता देंगे please. Just
okay. Inequality वाला बता
देंगे. जो सर इसमें जो दो है ना, जैसे मार्कोव इनइक्वालिटी एंड चेबिशेव इनइक्वालिटी, वो जो फॉर्मूला है, आई थिंक वो जो फॉर्मूला को एक्सप्लेन कर दीजिए एट द सेम टाइम प्लीज विद एन एग्जांपल. So actually I not get मतलब.
Okay, so Markov's inequality or Chebyshev inequality. Okay.
Yes.
So you'll from the next week, I guess there are so many other inequalities you'll be reading. So just make sure this at least is Markov's and Chebyshev is clear. You'll get the problem from Markov's inequality for sure in the exam. So just try to solve as many as problem you can solve. See, the Markov's is pretty simple. Only you'll get problem when Chebyshev is not. Okay. And Chebyshev with the bounded, like the bounded thing, like for example, for the probability, so that will lie between 130 to 70. Such problems you'll face issue. Okay. And the thing is, Chebyshev can be used. Chebyshev can have 2, 3 like other equations also. Same equations, but like for example, I'll tell you. Okay. The first is Chebyshev. How generally write the Chebyshev inequality? The probability of
absolute value of x.
The deviation of the mean greater than k sigma is less than equal to 1 k square, right? How generally write? See, this is my distribution. This is my distribution. Okay, this is mu, right? This is k sigma. So mu minus k sigma. This mu plus k sigma. If somebody is having any issue in remembering this equation, how can you remember that? So this is what this equation generally represents the probability that how it is if you are having the distribution, how generally you calculate the probability? You calculate the area, right? The area under this curve.
Yes.
If you have to this equation, what this equation is saying you, what is the probability that the x lies from mu plus k sigma and from mu minus k sigma to the minus infinity and mu plus k sigma to the sorry. So the area under this equation generally is asking you what is the probability such that the data set will lie from mu plus k sigma to the infinity and mu minus k sigma to the minus infinity. Okay, this is the area, and this should be, and the Chebyshev inequality is if this the probability, the area under this curve should be less than equals to 1 upon k square. How generally you calculate the k square, that I will tell you later. Okay, so the first thing is how should you remember this? So if you are getting this equation, the x, the deviation of x, the deviation of data point from the mean, deviation of data point, deviation of data point from the mean by k sigma and minus k sigma. So the area from mu plus k sigma to infinity and mu minus k sigma to minus infinity, what is the probability? And the probability, yeah.
Sir, यहाँ पे like what is the value of x and the k sigma? What is that sigma value here in this diagram which you have drawn now?
Sigma होता है ये the spreadness of the graph. This is the sigma is what? The variance, only the square root of the variance. Okay. Variance is the spreadness. So if you see, for example, if you are having normal distribution as this one, this will have been a different variance, right? This function will be having different variance. Okay.
Yes, I got
the more spreaded and the less spreaded. Okay.
Okay.
So here the value of x, like x minus mu, if you're saying, so value of x like on the line of on the x-axis it will lie any value, and from that point I need to calculate the area. What exactly it means that x minus mu mod?
Can you repeat that once more?
X minus mu mod, that equation is what, like here the x value, where does it lie? Is it lie on the x-axis, and from that point I need to calculate x minus mu, and then that will
see this equation is what? Probability such that x is lying from where? Mu minus k, sorry. This equation is probability that x is greater than mu plus k sigma plus probability such that x less than mu minus k sigma. This is the equation. This equation is same to this one. So the probability that data points is lying here or data points is lying here. What is the probability of that? That is what? Yeah. And if you have, so this is a one equation. Yeah. Okay.
One second, please. The first part where you said x is greater than mu plus k sigma, that is clear. Next part where you are saying it is less than mu minus k sigma, how did we arrive at that? Because it's greater than or equal to.
Okay.
Where
what is that mod x? Okay. One second. So if you are having equation mod x means what? Mod x greater than equals to alpha means what? X can be greater than equals to alpha and x can be less than equals to minus alpha. This is what you would have read in the earlier classes. So x, say for example, x is 5 or 5. Okay, this is 5, this is 5. Take that value x less than minus 5, like minus 6. This is hold, right? Minus 6 ka mod is what? 6 is greater than 5, right? This is holding.
Yes, greater than 5.
Holding
6 minus mod of minus 6 is always 6, so that part is.
So both the equation is holding. Both the equation. If mod x is greater than equals to 5, that means what? X is greater than 5 or x is less than equals to minus 5, right? This both the equation will hold here.
X is less than.
Okay, I'll tell you again. If mod x is greater than equals to 5. So either x can be greater than equals to 5 or x agar 5 se zyada to it will hold for sure. Like for example, x.
Oh yeah, sorry. Yes, got it. Okay, got it.
Okay.
Got it. Yeah.
This is what you have to explain. Like x minus this is what just I have explained you. this is what x should be greater than nu plus k sigma, or x is less than mu minus k sigma. X is less than q minus k sigma. This is both the equation. Okay.
Yes.
So it will hold for both. So this is the area. This is the area that you have to calculate. The probability that a data point is lying either here or either here. And और उसका boundation क्या है? Like the boundation of this probability is 1 upon k square. That should पक्का भी less than 1 upon k square. Okay. And now one more thing. If you have to calculate the area of this,
sorry sir. So यहाँ पे दोनों area मिलकर it will be less than 1 by k square. You mean to say?
Okay. Yeah. Okay. Now you have to calculate the probability of this area. So what will the probability of this area?
1 minus both of these.
So yeah. So if this is less than equals to 1 upon k square, the other Chebyshev inequality will be what? Should be greater than equals to 1 minus 1 upon k square, right? And the area and the value and the data point should lie between nu minus k sigma to nu plus k sigma, right?
Yes.
Okay. So two things is there. One is if the data point is lying from this point to infinity or this point to infinity, the probability should be less than equals to 1 upon k square. That is the one thing. The second thing is if the data point is lying from this, then the probability should be greater than equals to 1 or minus 1 upon k square. The two things is there that should be remembered always. Okay. So you'll get the problem for sure in the exam.
Yes,
so the second thing which you explained, 1 minus 1 by k square, which is the left out part from the first, is that what the lower bound is?
Yeah. So this is the lower bound. This is a higher bound. For the
okay, so the lower bound is something which is the 1 minus of upper bound always, right? So let's say they asked the question, find the lower bound of the case where it is.
Okay. Okay. I got your point. So lower, see, for example, if you're asking, if somebody's asked you this equation, and I've asked you, what is the upper bound of this equation? Upper bound, that the probability that x will lie, the data point will lie from nu to k sigma and nu minus k sigma. Okay. So the what is the upper bound of that upper bound that the data point will lie from here to infinity or here to infinity. The upper bound is what? If somebody is asking you, upper bound means what? It should be less than some value, right? That the maximum value it can go till 1 upon k square. That is the upper bound. Are you getting my point? See, if I'm telling you the maximum value it can go is 5. That is the 5 is the most, like the 5 is the utmost value that that something can get, right?
Yeah.
Yes,
so
sir.
This if less than equals to means what? This is the upper bound. Upper bound means the maximum it can get. 1 upon k square is the maximum value it can get, right? So it will be a pakka less than always, like less than 1 upon k square. And the lower boundary is what? Lower boundary means that's the minimum value of that probability. The minimum value means to the whenever you have been asked the lower bound. Okay, lower bound means the minimum value they're asking that. उससे ऊपर वाला मतलब जो minimum value हो सकता है उससे ऊपर ही जाएगा, उससे कम कभी नहीं आ सकता है. यहाँ पे they'll always ask you the upper bound. Upper bound, if they are asking the upper bound, that means less than equals to 1 upon. इससे ऊपर नहीं जा सकता. This is the maximum value that you can get. Are you getting my point?
Yes, sir.
So the lower bound in this case will be 0 basically.
Yeah, the probability of
it is like 0 भी हो सकता है, so like it can go till 1 by k square.
Yeah, 0
At most it is 1 by k square. If they ask lower bound of this specific equation, it will be 0.
Yeah, they'll not ask you the lower bound for this equation.
Okay.
They'll ask the lower bound for the other equation of the Chebyshev.
Okay. So the one which comes in between. So basically that minus 5 to 5. If it is in that range, it will be lower bound.
Yeah, in that case, generally we ask greater than equal. Hello.
We couldn't hear you for a while.
Okay, so are you able to hear me? Like my
yes, sir.
Yeah, now we can hear you.
Yeah, so okay, so should I write it or is it fine? Like, have I explained you in a good, proper way?
Yes,
or
sir. Yes, sir.
Please write it. Please write it.
Okay, I'll write it again. I'll write it in the so that you can just take the screenshot. Maybe it will help you.
Sir, we could also bring that into consideration, professor has explained about different forms of Chebyshev's, inequality. 3 or 4 forms he has explained. You can explain those forms and
okay, I'll just try to write it. One method, one way I told you already. Probability of x minus mu ka mod greater than equal to k sigma less than equals to 1 minus k sigma. This is the one. The second is what? This is the area, this is area. So ye wala area. And if you have to calculate for this area, this is what? Greater than equals to 1 minus k square. This is the one, this is the second. Right?
Yes.
The third one.
So can you write the expression for second one?
Okay, I'll write it down. The probability says that x will lie from mu plus k sigma and mu minus k sigma.
So in this case, it will be a lower bound, right?
Yeah, this is a lower.
That is a low. This value, whatever 1 minus 1 by k square, that is a lower bound because the probability can go more than that, but it will never be lesser than that.
Yeah. Correct. Too correct.
Thank you.
Sir, could you repeat this? First one is looking at upper bounds and second one is looking at lower bounds.
Yeah.
Or am I getting it all wrong?
No. You're correct. So upper bound means what? The maximum value it can get, right?
Yes.
Upper bound means this is the maximum value that you can get.
Okay.
1 upon k square. This is the lower bound. Why we are saying lower bound? Because this is the minimum value that you can, because it's a greater, always it will be greater than 1 minus 1 upon k square, right? Greater than 5 means what? 5 is the minimum value. This is the lower bound, right?
Yes.
Yeah, this is what I'm trying to say. Okay, so and the other thing is what? Other thing is you can write the same thing can be written in other form also. Like for example, probability says that mod of x minus nu greater than equals to some t is what? Less than equals to variance of x upon t square. So this is the same thing that we are writing in a different way. So these are 3 equations. Like only you will be using these 2 equations only. Third equation is the how we are getting this other equations. Like generally we write what? Variance. How generally we get the Chebyshev? This is we are getting from the Markovs. How generally we write the Markovs inequality? I'll write it here. So Markov is what?
Sir, यहाँ पे that k value is a constant or is that any other formula we need to calculate that?
Okay, well, I'll tell you how to calculate that. So k is simply see, for example, one question was there in the. I'll just go through that question. I'll write it the Markovs also. So I'll just go through this. I'll write Markovs and I'll try to solve some question and then bind up. And if you're having any issue after that also, you can just like message me or WhatsApp, whatever you're like trying to like. I'll try to solve this after tomorrow. I'll be back to my home tomorrow and then. Okay, so what is that? Markovs. So we are getting, you already know that how we are getting the Chebyshev. Chebyshev generally we get from the Markov's inequality itself. Okay, so the probability of getting x greater than equals to some t is what? Less than equals to mu upon t. How generally get the Chebyshev? So Chebyshev we can just write probability of what? X minus mu ka whole square greater than equals to t ka whole square equals to what? X minus mu ka whole square upon t square, and this generally we write as a variance of x, right? So Markovs and Chebyshev is almost same, but the way of but the different way to represent similar things. Like Markov is pretty simple. If you're asked, like if somebody has asked you to calculate with the help of Markov, Markov then generally doesn't have any other forms. Okay, only one form is there. If somebody asked you the mean value of some marks of the class, marks of the maths subject of a class like 10th class is 50, and if somebody asks what is the probability that the marks is greater than 10, what do you judge? You can just tell the marks should be less than equals to the probability that the how many percentage of the people have got marks 10 greater than 10%, 10 marks, right? If the mean is 50, what is the probability of that? So you can directly write 50 upon what? Am I doing some mistake or what?
2 upon 10 will be 5.
Yeah, so 1 upon 5, right? No, the probability can't be 5, right? So maybe I'm like, oh, okay, just for example, if the mean value is 50, and if somebody has asked you what is the probability that the value probability such that the marks of the students are greater than, what is the probability, how many, like, probability of getting like greater than 80 marks, what would be that if I open 8, right? So the maximum probability that the portion of the maximum portion of the student would have got more than 80 marks would be what? 5 upon 8, right? So why for the 10 marks it was coming more than 100, more than the 5, more than 1? Because the already we are having the mean value as what? 50. And if I'm asking for greater than 10 marks, so probably it must be greater than 1, right? That's why we are getting probability as 5. So yeah. So the Markov is
Sir, I'm sorry, I couldn't follow. I mean, I got that the average marks of the class was 50. And then what are we trying to do?
Okay, so I'm just trying to say that what is the probability that the marks is greater than, what you can say, 80 marks? What portion of the student would have got marks greater than 80? So what is the probability of that? So you can directly write that mean upon t. Mean upon t is what? T, I'm asking for the 80 marks, 5 upon 8, right? Why in the starting case I took as 10 marks? So what is the portion of the student would have got greater than 10 marks? Okay, so it was coming as 5. Why it was coming as 5? Because if the mean is 50.
So I'm so sorry. Can you please write it down as you're saying? It's kind of like difficult for me to follow.
Okay, so it's just a simple example. Okay, I'm just so I just telling if the marks of the class is 50 for some subject, for example, for maths. So I was just asking what proportion of the student would have got marks greater than 80. So the probability would be what? Probability that x greater than equals to 80 would be what? Less than equals to 50 upon 80. 5 upon 8 portion of the student, right? This is what I was saying. Nothing important.
Okay.
Yeah.
So for 10 it was coming wrong. So can we summarize that this holds good only for greater than mean?
So for 10 it was coming more than 5. Why
yeah.
it was coming more than 5? Because like
that 10 is less than mu, right? 10 is less than mu.
Yeah, that's why it was coming.
So can
it's just a boundary.
Yeah, so can we conclude that this inequality holds good only for values greater than mu, greater than mean? Can we conclude that?
Yeah, you can conclude that, because if the value you are considering at less than mean, every time it will come more than 1.
More than
right?
1, yes.
Why it will come? It will just tell you. So Markov's doesn't tell you the exact anything. It just tells you it should be less than 1. That is correct, right? The probability would be less than 1. That is pakka, right? So if the probability, if somebody asking you for some probability stuff, and if you are saying the probability must be less than equals to 1, that is correct only, right? You're just saying an assumption. So Markov is giving you an assumption, right? So it's not always correct. Like it's not even close to. If you just go and try to solve some stuffs, you'll see that Markov is not even closer to whatever the probability you're getting. Okay, so Chebyshev is a bit good. Even more, you'll read in 4th week or 5th week, there are other inequality. You'll see that how that Markov and Chebyshev is very, like, appears to be very, what you can say, far from the final answer, whatever you're getting. Just a simple, the Markovs and Chebyshev is just a simple thing just to, what you can say, learn. But you'll learn the more vast inequality where you'll see that whatever the value you're getting is a bit closer. Markovs is too like far away from your answer. Right. This is just a foundation you'll be getting from the Markovs. Okay, that's it. So I'll try to. Okay, so now if you're having any issue, you can ask me, and I'll solve some problem.
Can we discuss one activity question? Yes, 3.7, sir.
Okay,
sir, I just wanted to ask one thing. Basically, Chebyshev is checking whether the z-score of a particular value is greater than a certain k, right?
Z-score.
Yeah, because it's looking at x minus mu being greater than k into sigma. So x minus mu divided by sigma is the standard z-score, right?
Yeah. Okay. I'm getting your point. So it's not the Z score, whatever you're talking about. It's not about that. Like you can, like, if the formula is like this, like x minus mu, and you have just divided everywhere the k sigma, and then you're like,
Yeah.
it's
I mean,
not.
if you divide x minus mu by sigma and you're checking it whether it's greater than or equal to k, so we are basically looking whether the standardized value is greater than that k.
You can say in a one way that this Z score is greater than whether the whatever the data points we were having after converting that
Into
simply a
standardized.
standard. Yeah, you're just converting that into a standard thing, and then you're saying, okay, this is going away from how many sigmas and all. So that you can say, okay, yeah, that is also fine.
Question number 7 of this week, this lecture. Lecture number 7. Question number 7. Sir. One activity question.
Question number 7 of
this
7.
one. Sir. Yeah.
Which question?
Yes, sir. 3.7. Lecture number 7. Question number 7. Yeah.
There's no 7th question in this.
Just a second. Yeah, this one only. This one. Sorry, this one only.
Okay.
3.
So see, I told you. So what has been asked here? What is the upper bound on the probability that the number of times the coin lands on head is at least 130 and at most 70. So at most and at least. So see, I told you that how will you approach with this question? So okay.
No, I'm getting confused because there is something called OR, right? So whether I need to add these two probability or what? First of all, I have to calculate for 130, then 70, then I have to add these two probability or what?
Okay. So this is the plot. This is 130. This is 70, right? Okay. And then the probability that number of coins land is at least 130.
Sir, can you please explain the question, please, so the rest of us can get.
So if you are just tossing a coin 200 number of times, okay, you are just flipping a coin 200 times, right? So now you have to calculate, find the upper bound of the probability that the number of times you will get the head should be at least 130. So it should be greater than 130 or should be less than 170. Okay. So the value of the number of, if you are tossing the coin 200 times, what is the probability that you will get more than 130 times head or less than 70 times head? So what you has been asked, you have to calculate the area of this and calculate the area of this. Are you getting my point?
No, sir. At least 130 means yes, right hand side. This right hand side.
At least 30. At least 130. That means
at least 130 means right hand side. At most 70. At most 70 means maximum
at most
70.
Means, at most 70 means maximum is 70.
Correct. So when I say maximum 70, then it should be within 70, no? Like it should be less than 70 at most.
This is less than 70, right? This area and this area.
Okay.
Okay. So for this, which formula we were using? The first equation, 1 minus k square, 1 upon k square. Right? And they are asking upper bound also. So less than equals to 1 upon k square. That means you have to calculate the value of k only, right? How will you calculate k here? Okay, that's the good thing. So you have the mean. Mean is what? How will you calculate the mean? This is a binomial.
This is a binomial.
No, I have calculated, sir.
No. How will you calculate binomial in the binomial? Because here either you will get head or you will get tail.
NP. Mu is NP, sir. Mu is NP.
NP. NP means what? 200.
200 into half.
50,
100. Yes.
100 is the mean, right? So what was the equation? What was our equation? Nu plus k sigma is equals to 130, right?
Yes.
Okay. Mu is what? 100. So k sigma is what? 30.
Yes, sir.
How will you calculate sigma?
That NP into 1 minus P. NP into 1 minus P by variance. I will take a square root of that.
Is the root?
Yes.
Right. So this is what? 100 into 1 upon 2 root
50. 5 root 2, sir. 5 root 2. Yeah. 5 root
50. 2. Right?
Yes.
Now the upper bound 1 upon k square. K is what? Less than equals to 1 upon k is what? 30 into 30 into 50. It got like 5 upon 30 into 3. So you got 6. So it should be less than equals to 1 upon 18. Have you got the point?
Okay. Sir, I was going wrong that I was calculating once for 130 and then again for 70 and then I was adding these two probabilities. So I was getting 2 by 9.
Every time I've told you, just plot this graph, okay, and then see which have been asked. If they're asking for this area, just go with this formula. If they're asking for this area, 1 minus 1 upon k square. In k you can calculate, okay? K will calculate.
K is 5. Because that word is there, no? That or word is there. So I was thinking that I need to calculate these two probabilities separately and then I have to add. So I was doing wrong.
Okay, no worries.
Sir, here the event was basically a Bernoulli event, right? It was distributed to Bernoulli. If it was some other type of distribution, then we would have to be very careful while calculating mu and all that.
Yeah. Then in those cases, you have to calculate the mean and variance. So I don't think so they'll ask you such a difficult problem where you have to calculate the mean and then variance.
Yeah, because then we would have to know the variance formula also. We would also have to know the mean formula also.
Yeah.
For that distribution.
Correct. Okay, so I guess so. If you're having any other issue, you can ask me in just like 2 to 3 minutes. I'll have to go, so I can't take more. Like the session can't be much longer.
Sir, can you please send your email ID please so that we can connect?
What?
Your email ID please so that we can connect.
I'll just message you on the chat box as well. So you can. I'll just write it here itself. Okay. So you can just write Vishal @online degree .ac. What is that? .iitm.ac.in.
How to tag on discourse forum, sir?
@atm.ac.in. You can tag me @Vishal POD. I'll just write it here also. I'll just copy this. So you can mail me, message me, whatever you want to do, you can do. After tomorrow, I'll be totally free. Because I got some call, but I was really busy. Like not like because of the event only we were busy. So I just wrote on the chat box also. You can just copy it. You can mail me whatever you are having doubt. We can discuss it. So okay.
Yeah. Thank you very much, sir.
Okay.
Thank you so much, sir. Really understood a lot.
Thank you very much. Thank you.
Thank you, sir.
Night.
Thank you.
Thank you everyone. Thanks a lot. So yeah, so if this is my mail ID, you can mail me. I just wrote in the chat box also. You can just copy. You can just mail me, or you can tag me in the discourse @Vishal POD. So thank you everyone. I'll just drop down now.
Thank you very much, sir.
Okay. Thank you everyone.